Hello everyone, welcome to solve this math Olympiad algebraic problem, and we have n factorial equals to n cubed minus n, and we solve this problem for the values of n. So here we use the definition of factorial sign. So now first we little bit explain the factorial. So if we have n factorial, so by according to the definition of factorial, we write this as n times of n minus 1 into n minus 2 and up to so on 3 multiplied by 2 multiplied by 1. So this is the formal definition of factorial. So now we break this definition up to the any term which we want. So it means that if we break this product up to n minus 2, then we make the factorial sign here. So it means that we write this definition parallel to n times of n minus 1 into n minus 2 factorial. And similarly, if we break this product up to n minus 1 term, so we write it as n times of n minus 1 factorial. So now we move towards the given question statement, and we use this definition on the left hand side. So we just substitute n factorial equals to this one, and we take common n from the right hand side, and we move further to solve for the values of n. So now the given equation implies that we put the value of n factorial here, and we obtain n times of n minus 1 into n minus 2 factorial equals to, we take common n from the right hand side, and it will becomes n times of n square minus n. And now in the next step, we focus on the right hand side, and you see here we have n square minus 1, and we know that the very well known algebraic identity, it is a square minus b square equals to a minus b times of a plus b. So we use this nice formula on the right hand side of this equation, so that this equation becomes n times of n minus 1 into n minus 2 factorial equals to n times of, we have n square minus 1, it is equals to n minus 1 times of n plus 1. So now in the next step, you focus on both of the sides, and we cancel the like terms. So we have this n is cancelled out by this n, and n minus 1 is cancelled out by this n minus 1. So now we obtain n minus 2 factorial equals to n plus 1. So now we made a little bit simplifications here, and we focus on the right hand side, and we convert our n to n minus 2. So we write it as n minus 2 factorial equals to n minus 2 plus 3. So we just break this plus 1, and we write it as minus 2 plus 3. And you see here we have n minus 2 be the common term, so that we take uh, n minus 2 equals to x, and it will be written as x equals to n minus 2. So now we substitute this value of x in the above equation, and it will becomes x factorial equals to x plus 3. So here we again break this x factorial, and here we use this definition. So we have n factorial equals to n into n minus 1 factorial. So our x factorial equals to x into x minus 1 factorial. So we break this x up to x minus 1 term, and it will be written as x times of x minus 1 factorial equals to, here we have x plus 3. So now in the next step, we move this x to the left hand side, and it will be written as x times of x minus 1 factorial minus x equals to 3. So here we take common x, and we obtain x minus 1 factorial minus 1 equals to 3. And now we move this x to the right hand side, and it will becomes x minus 1 factorial minus 1 equals to 3 over x. And we move this minus 1 to the right hand side, and it will becomes x minus 1 factorial equals to 3 over x plus 1. So in the next step, we just find the values of x by inspection, and we find those values of x which satisfied this equation. So now we copy down this equation here, and we write it as x minus 1 factorial equals to 3 by x plus 1. So now we put some values of uh, x, and we check which value satisfy this equation. So here first we put x equals to 1. So now when you substitute here x equals to 1, so this equation will becomes 1 minus 1 factorial becomes 0 factorial equals to 3 over 1 plus 1, and it is equals to 3 over 1 plus 1 is 4, so 0 factorial is 1, and it will becomes 1 equals to 4, and we know that it is not possible. So if it is not possible, then we rejected this case, or we reject the value of x equals to 1 because it is not satisfy this given equation. And now we check it at x equals to 2. So now we same substitute x equals to 2 to this equation, and we have 2 minus 1 is 1, and 1 factorial equals to 1, and here we put 2, so it will becomes 3 over 2 plus 1, and we know that 3 over 2 is 1.5, and 1.5 plus 1 becomes 2.5. So here you get 1 equals 2.5, and it is also not possible or not satisfied the given equation, so we rejected this value also, and we move further to put x equals to 3. So now we substitute x equals to 3 in the given equation, and when you substitute here x equals to 3, it will becomes 3 minus 1 is 2, and 2 factorial. So we obtain 2 factorial equals to 3 over 3 is 1, and 1 plus 1 is 2. So 2 factorial equals to 2, and 2 equals to 2. So it means that x equals to 3 satisfies this equation. So we have x equals to 3 be the solution, and now we back substitute the value of x in this equation. So we put the value of x here. So now this equation will be written as, so now we copy down this equation, and it is written as x minus x equals to n minus 2, and here we substitute the value of x equals to 3 here because we find the value of x which satisfied this equation. So now we substitute this value of x here, and it will becomes 3 equals to n minus 2, and we move this minus 2 to the left hand side. It will becomes 3 plus 2 equals to n, and we get the value of n equals to 5. So n equals to 5 be the final solution of the given question. And thank you so much for watching this video. Please subscribe to my channel for more exciting videos.